In this episode, we discuss the combination of AutomationML, OPC UA, and the Asset Administration Shell in the context of Industry 4.0. My guest on this episode is Dr. Miriam Schleipen. Miriam is the Chief Research Officer at EKS InTec, dealing with semantic interoperability in automation systems based on digital twins and their application in automation environments. She is the head of the joint working group of the OPC Foundation and AutomationML. She leads the German Glossary Industry 4.0, and she also participates in national and international standardization groups dealing with semantic interoperability in Industry 4.0. Miriam studied computer science and holds a PhD in engineering from Karlsruhe Institute of Technology. Between 2005 and 2017, she was engaged in applied research on manufacturing execution systems and interoperability at the Fraunhofer IOSB, where she was in leading positions for 8 years. From 2017 to 2021, she worked as a lead software architect for Siemens Digital Industry, where she was a member of the HMI platform software architecture team. Quick thank you to our sponsors. This episode is made possible by our friends at HiveMQ, who are providers of an enterprise-grade edge and cloud-based MQTT broker, and Opto22, manufacturers of reliable industrial controllers for automation and IIoT applications. So please do check them out to help support this channel. Welcome to the 4th Generation podcast here on Industry 4.0 which is a series of weekly interviews designed to help you learn Industry 4.0 and IIoT from some of the world's leading practitioners. So make sure to subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and connect with me on LinkedIn at Kudzai Manditeresa. Now, here is my interview with Miriam. Okay, Dr. Miriam, thank you so much for taking the time to join us today. I would like to welcome you to the show.
Thank you very much for having me here.
Okay, thank you. Okay, so today I want to talk to you about AutomationML, OPC UA, and the Asset Administration Shell in the context of Industry 4.0. Okay, so to begin, can you give us an introduction to AutomationML and also outline its role in Industry 4.0?
Sure. So in brief, AutomationML is an open and standardized file or data exchange format. It's tool and vendor independent, and it handles engineering information in automation plants. So this means that it's kind of designed for cross-company and is interdisciplinary exchange of the engineering or planning data you have for your manufacturing and process industry plants. And it's standardized in the context of the IEC.
Now, when we talk about automation ML in Industry 4.0, it is often associated with its integration with OPC UA. So what I would like to find out is, why do we need the AutomationML and OPC UA integration, and how does that integration work?
Yeah, as I said, AutomationML handles engineering data. So this means that AutomationML is based, I would say, in the planning phase of the life cycle. So this means that it's really before the plant starts its real work until the virtual commissioning. Maybe you keep also data in parallel to the real operation, but AutomationML really focuses on the engineering phase. Whereas OPC UA is coming from the operation phase, means that this standard was designed for communication and also data exchange during the operation phase of plants. It integrates different hierarchy levels and vertically, but also horizontally. And this makes it somehow possible to combine those two, because sometimes in the AutomationML, there is data which might be interesting to be kept over the operation phase, which maybe changes during the operation phase. And that's one of the use cases where you can combine AutomationML and OPC UA. If you integrate those data of the AutomationML model into the OPC UA information model. And the other way around, if you have data coming from the operation phase, which might be of interest already during engineering, for example, configuration data for your OPC UA infrastructure, or also other information which is coming from the operation phase, such as calculated KPIs, and is maybe interesting for the next engineering phase or re-engineering. And these are two possibilities, to combine those two, and both are fixed already since, I think, 2017 in standardized documents published by the OPC Foundation and by the AutomationML organization. And as we were identifying those use cases, these two organizations started a joint working group, which was already established in 2014, and which is working already for some years on these common, I would say, use cases which occur in practice.
Oh, okay. Just to follow up on that question there, what sort of mechanism is used to implement that integration? Do we have like a companion specification for AutomationML? Could you expand on that?
Yeah, exactly. So on the side where we are, I would say, integrating AutomationML in OPC UA information models, it is exactly what you mentioned. There is a companion specification which was published in 2017, which is mentioning how to map AutomationML model information into OPC UA information models. And on the other way around, there is a best practice recommendation. This is on the AutomationML organization side, which was already published also, I think, in 2017, which is called the best practice recommendation on data. On this data configuration data for OPC UA system configuration. So these two specifications are describing how to combine those two standards, I would say.
Now, moving on to asset administration shell. I mean, from what I gather from research and all, the asset administration shell is a big part of Industry 4.0. Could you give us a breakdown of the fundamentals of the asset administration shell?
Mm-hmm. So to briefly summarize the asset administration shell, I would say that the asset administration shell provides information about assets which are of importance for one or several players. It provides a unique identifier to this asset, and additionally a generic interface to access information concerning the asset. So this means that if you have assets and you have additionally this asset administration shell, this asset administration shell makes it possible to manage those assets and to access all the information at one place, independent of the technology and independent of the company, because the asset administration shell is something which evolves over the life cycle. So this means that you can have documentation information coming from a device vendor. Additionally, you include some simulation submodel, for example, when you are in the virtual commissioning phase. You can add in your operation phase additional KPIs concerning, for example, energy consumption, and all these things are somehow linked together via this asset administration shell, and it provides mechanisms or interfaces so that you can find this administration shell and that you can access the information which is described there. And maybe one thing which is really important is that there are different types of asset administration shells, and this is somehow confusing if you're discovering one type or the other type, because you have a passive type, one, which is just, how to say, a serialized file. So this is really pure file description of your assets. Then you have the type 2, this is the reactive asset administration shell type, and there you have the possibility to access the information described inside the asset administration shell. And there is a third part, and this is really the future thing, that you have proactive type 3 asset administration shells, which interact directly, not with some other system, but with other asset administration shells, so that all the assets get their administration shell and all the administration shells are interacting with each other, and you do not have any human or system in between that. So they are talking, it's often called an Industry 4.0 language.
Oh, okay, that's interesting. Now, well, since the asset administration shell basically provides an interface to the information of an asset, is it possible to define an information model inside an asset administration shell? And if so, how does that work?
Yeah, the asset administration shell has a meta model description inside, and some mappings to different, I would say, serialization standards and also communication standards. And the main concept, which has to be mentioned there for the definition of the information model inside an asset administration shell, is the concept of the submodels. So this means that not all of the information is just summarized in one big tank inside the asset administration shell, but everything is divided into submodels. So this means that, for example, if you have simulation data, you have a submodel for simulation. If you have identification data, you have a submodel for identification. And if you have documentation data, for example, PDFs or something else, you are having the submodel documentation. And this concept of the submodels makes it possible to include different aspects, and makes the concept of the asset administration shell really modular and flexible.
Oh, okay. Now we've already described the combination or the relationship between AutomationML and OPC UA. Could you describe for us the interrelation of the asset administration shell and the AutomationML?
Mm-hmm. So now it's really getting a little bit complicated, because, as I said, the asset administration shell has these submodels, and two types of possible submodels can be represented by AutomationML models, or also OPC UA servers and corresponding information models. So this means that if you have, for example, a description of your engineering data concerning your CAD data, for example, and you want to have that accessible via the asset administration shell, you directly include the whole AutomationML model as I call it blob. So you do not map everything into the asset administration shell format, but you include it really as a blob, and only define a reference to that blob. Means that it's accessible via the asset administration shell, but somehow the submodels are really separated. And on the other hand, there is the possibility, or the definition of this meta model I already mentioned, and you have the possibility to have that represented as JSON, but also as AutomationML format. So you can describe asset administration shells directly in AutomationML. But these different mappings, and the same thing is somehow corresponding on the OPC UA side. You have this REST API, which is defined for accessing asset administration shells, but you could also have asset administration shells inside the OPC UA server, which are then accessible via the OPC UA standard mechanisms. For example, that you can discover them, you can browse them, you can access all the information corresponding to that. So from at least from my point of view, the asset administration shell is something which is really on, I would say, on top of the production, because it makes these connected worlds scenarios possible. So this means that you have different companies over a value stream, you have different life cycles which are combined together. And if you then have this asset administration shell, you really have the power and the necessity, and also the maybe also the opportunities you need to realize that, and to spend this extra effort for creating asset administration shells. In case you are only in the engineering phase, for example, from my point of view, it's the asset administration shell is something which you could use, but it's not necessary to use it. So this at least is one point which is always a little bit misleading, I would say, because you have somehow to distinguish how all these three standards, and the three are not the only ones in the automation domain, because there's a bunch of it, where you need or where you can apply which standard, and where it makes sense to combine them, and where you do not have the necessity to combine them, for example. So but at least it's possible to combine them.
Oh yeah, that's interesting. Now maybe jumping back to automation ML, because you mentioned about being able to describe assets in the automation ML. Now, what tools software tools would one use to undergo such a process of describing assets in automation ML?
Yeah, and in fact, there is an AutomationML editor available, which is somehow designed for discovering the format and creating your first models. So this is something which you can use, also in when you are talking or collaborating with other people, so that you have a visual editor to open models, to change them, to show them to others, to discuss them. On the other hand, there's the AutomationML engine, it is called, and this is this programmatic interface for accessing AutomationML models, because AutomationML is based on XML, and the AutomationML engine is a .NET possibility, or .NET based possibility to access and also to manipulate AutomationML data. But in fact, as I said, it is XML, so you may also access this via any programmatic language you want to use, which is able to deal with XML.
Oh, okay. So, well, with the asset administration shell, because obviously talking about the issue of sharing and interoperability, I mean, for the asset administration shell to undergo that widespread adoption and simplified adoption, there has to be some sort of standardization. It has to be standardized. So, what would you say are the conditions that are required for standardizing the asset administration shell?
Currently, it is already, I would say, in progress, because there are some standardization activities in the ISC. I would say they are, compared to AutomationML and OPC UA, they are really at the beginning, because there were some working groups founded, and they are intensively discussing on the document. There is an IEC standard, at least part 1 for the standard, in the CD stage. So this means that the committee draft was submitted and is under review by all the other countries. And this will be the first step towards international standardization. On the other hand, we have those activities also in the Industry 4.0 context concerning the RAMI, the Reference Architecture Model Industry 4.0. And this was, there was already in 2018 or 17 an first German part created there, and there is an ongoing activity of harmonizing that with all the other reference architecture models which are coming from all the other countries, and both activities are located in the IEC. So at least this definition of the meta model as a standardized format, which doesn't change every second month, for example, so that it might be or might have the possibility, and also you might want to be sure that if you implement it, it doesn't change every second day because there is some improvement or something else. But this is really the way standardization works, that you have stable releases, which you might base your implementation on, and you are really sure that this, for example, is stable for at least 3 years, for example. So that if you invest a lot into the implementation, it's not that every second day you have to re-implement or readjust your implementation. And I think that's really one crucial point, because all this interoperability topics and all the free standards are really dealing with interoperability. They only work if you are really, really sure that everything is defined and standardized, which you might want to implement. And beside the fact that all the free standards have a meta model approach, which makes it possible to not so that you do not have to standardize every really single detail, but you standardize the meta model, you standardize the access to the meta model, and you are sure that you can base your implementation on that, and you also standardize semantics in this context. But this meta model approach is really, really good for having a long life standards, but nevertheless have the flexibility to react also on changes which are currently happening in the industry.
So, well, clearly these three technologies, AutomationML, OPC UA, and the asset administration shell, have a symbiotic relationship as far as Industry 4.0 is concerned. Now, what are the clear benefits and use cases of the combination of these three technologies?
Yeah, at least if we are talking about those, I already told it, connected world scenarios, where we have different companies interacting with each other. And to give one example, if you have a device vendor which produces devices for a specific use case, these devices are sold to any, for example, plant operator. And there are additional companies, like, for example, our company, EKS, where you have a virtual commissioning of the plant, or also the digital twin of a plant, where you have analysis on the data the device produces. There you have really a value chain and different partners from different companies involved, where the application of all the free standards makes sense. Because, for example, if you have the device, you might want to exchange engineering data of the device with your simulation environment, but also with your real operating environment. Additionally, you might want to have operation data, and this data coming from the operation phase might be produced in the real world, but as well you can produce this as well in the simulated environment, for example, where you only couple real controllers and simulate the rest of the plant. And this operational data and the corresponding interface, for example, their OPC UA is really the standard to be chosen beside all the other network protocols and also feed protocols which are existing. And the third thing is that, for sure, if you have this engineering data, you have the operational data, you might have additional data concerning documentation or also the identification of the device over its whole life cycle until it's recycled, for example. And you might want to, for example, calculate your carbon footprint of this, either the produced product or the device. And there, all this information comes together. And this means that there, the asset administration shell is really the thing which you might want to use there as standard, because you have those different parties, you have those different also legal entities. They have to be somehow combine information together, but they must also be aware which information is shared, which information is accessible to which party, and these use cases are really of interest in future scenarios, I would say, where all these three standards are coming together.
Interesting. Now, well, let's focus on the asset administration shell again. I mean, you might have already touched a bit on that, but when it comes to the implementation of the ecosystem of the asset administration shells, are there any best practices that you would like to share with our audience?
I would say, at least from my experience with all these three standards, for the engineering phase, I would really prefer on using AutomationML as a standard there for exchanging complex information between tools which are used in practice, including the whole construction phase. On the other hand, for the dynamic exchange of data, which is which really focuses on the timely delivery of signals and of the corresponding process values, I would go for using OPC UA if you might want to have a vendor independent technology. And additionally, if you have something over the whole life cycle, this is really where the asset administration shell makes sense. So you can have a mix and match between this asset administration shell core, the submodels and serializations, and also the other technologies, so that you can really take the benefits from each of them, but combine them together. And I would not go for any, I would say, particular solution where you try to use, for example, only OPC UA and do not combine it with other things, or where you try to do everything with the AAS and remodel things which are maybe already there. And this is one best practice I discovered during the last time, in which we also follow at EKS, is that we try to decide from use case to use case, that we try to see which things are really making sense, because we're using all the free things, for sure, AutomationML and OPC UA already for a long time, the AAS more in the research context, but that you have really to decide what makes sense and how you mix those things together. But it's not black or white. It's not either the one or the other, but it's really how you can benefit from each of the strengths of these formats and technologies.
Oh, okay. That makes a lot of sense there. Now, well, one concept that is really gaining traction as far as smart manufacturing is concerned is that of the digital twin. So what I would like to find out is what roles does these three technologies play in implementation of the digital twin?
I would say so, or in the last time, the AAS was somehow at least interrelated to the digital twin, or was placed as digital twin technology. But in fact, for me, the digital twin is somehow the digital representation of an asset, and there are different I would call them types of digital twins, because you might focus on the digital twin of a product, for example, where you have quality data, where you have maybe things which are concerning documentation of the product, or some similar things. And I would distinguish the digital twin of a production resource, so more the plants, because this is what we are in EKS are normally focusing on, that you have a plant, you have all the production resources, they are interacting together, you have the behavior, their 3D geometry, all those things. And this digital twin of the production resources for sure has also to handle the product, because what do the production resources do during the production process is that they are producing products. So it means that at least you need to have any model for the product, but it's really somehow different on which things you are really focusing. So if you are more focusing on the behavior of those things, either the product or the resource, or if you're more focusing on information, so more passive information collection, to gather all the data which is occurring around, for example, a product during its whole life cycle, including the recycling and everything. And these are really very, very, very different things. And there's no, I would say, single definition of digital twin. There are several definitions. I would say I know directly more than 10. There are a lot of differences between those definitions, but to briefly summarize it, for me, digital twin is just a digital representation of something which is, I would say, existing. And this is already one discussion point, because existing means that it must be there in the physical world, or it might only be one information part. And so this real and virtual point is also somehow misleading, because, for example, if you are planning something like for example, you are planning your production plant, and at the point in time where you're planning this thing, it's not yet there. So it means that you're completely in the virtual world, but you're planning the real thing, then it's at some point in time really existing. And so there are a lot of discussion points concerning this definition of a digital twin, but as I said, at least some digital representation.
Oh, okay. Yeah. All right. Well, now still on the concept of digital twins, a while back you shared a post about distributed digital twins. Could you briefly explain to us what distributed digital twins are all about?
It is, at least for us, this means that you have different parts of the digital twin. And one part for sure is the description or information model, including the 3D geometry, the kinematic model, maybe also some signal lists or other things concerning the thing or the asset you are representing. And additionally, you might have the behavior of parts of these digital twin. So it means that there are technologies and standards, for example, the functional mockup interface, where you are able to encapsulate the whole behavior and use or execute this behavior by so-called co-simulators. And this is really one promising additional technology, because you're able to encapsulate your behavior. You can couple different parts of your, for example, of your production plant together. So you have on the one hand the 3D simulation, you have on the other hand the behavior simulation, you have a co-simulation including those encapsulated simulation models, and all these things, if they are coming together, this is somehow the distributed digital twin. And for sure we have technologies like, for example, Action Cloud, and possibilities like containerization technologies, where we are able to distribute those things. So it means that they do not have to exist on one place, but they are really distributed, not only in the sense that these are different aspects which are described, but more in the sense that you can really distribute the execution of them. And you may have 3 different simulation parts for one product, for example, one which is caring about your energy consumption, the other is caring about your behavioral model, and all those things can come together without any monolithic solution. And I think that's one of the future concepts, that you do not have any big framework which is coming from one vendor, but that you have really many different parts coming together in an open ecosystem, which are combined there together.
Oh, okay. Yeah, I think that makes a lot of sense, actually. Okay, so, well, now in conclusion, could you first of all tell us more about the association behind the AutomationML, and then also tell us more about your company, EKS.
Mm-hmm. So the AutomationML Association is somehow the user organization for all the parties which are using AutomationML. Means not that you have to be member to use AutomationML, but if you want to really form AutomationML and further develop it, this is the organization which is caring about how the format is handled, how the standardization strategy is, and how the dissemination of this format is brought towards the market, and it somehow supports all the users which are using AutomationML in their implementation, specification, modeling. It provides software packages like this AutomationML editor and engine we've already talked about, but also shares knowledge about the format and provides a possibility for trainings. And it was founded already 15 years ago. 13 years ago, 13 years in 2008. And a lot of companies which are really pushing the standard forward are member and active member in this organization, and somehow it's organized like all the organizations, like also the OPC Foundation. There are working groups concerning specific topics. There are is some technical advisory council, which is I call it holding all the things together, and there's a board which is there for taking at least the last decision on some things. Yeah.
Oh, okay. And then EKS.
So EKS, my company, is dealing or is mostly working in the virtual world. So we are doing software development. We are doing design and virtual commissioning of complex production plants, and we have a range of services which we provide to customers. So this means that we are doing everything in the complete digital development process. We're having an in-house development which is called RF Suite, which is realizing virtual commissioning of complete production plans, and is also the base for our understanding of digital twins and also digital shadows of production plants. So this means that this RF Suite is allowing not only the virtual commissioning, but also the analysis and also predictive maintenance of real plants. And at least EKS is a small, medium-sized company, but we are really active also in the research part. So we are currently involved in I think 4 or 5 international research projects, and are always heading for the next level of those applications of standards like AutomationML, OPC UA, and also the asset administration shell.
Okay. That brings us to the end of this session. Thank you again for taking the time to come out and share your insight with us.
Thank you very much.